So, yeah, so to do my quick validation of the formulas, I will set the radius to unit length, which is 1, right? And also the width will be 1, and the height will be also 1. Just switch everything to unit length parameters, and I will just, selectively say, okay, right now, let me just populate my collection with only one circle. And of course, that total area should come back as the area of a circle with the radius of the 1 unit length, right? So let's just say build again. I'm not interacting with the user, so I'm just making changes, and if I do that, then I need to every time I make a change. So that's that is my if you recall, this is my pi times 2, so that looks correct, right? So this is like this number multiplied by 2, multiplied by square 1, which is 1, and therefore it seems right. Right. So likewise, I just still want to check the rectangle one by one, just to make sure that when I run it. So again, I need to quickly build this, and once I do, I just run it again. So this time, when I use rectangle with width and height 1 and 1, then of course my total area is 1. Okay. All right, so that's fine. This is good enough. I can perhaps improve my output by changing the total area to say that I want a fixed floating point format, which is done with the fixed manipulator in front of my output. And for this, I need to include IO manip, I think that's the header. Yes. Let's build this, right? And if I run it, so this time you can see that at least I'm not confusing myself, that I'm still looking at a floating point number, but obviously the default fixed precision is like 6 significant digits after the floating point. So just to be consistent, right? And so this is what we have discussed prior to this class, is that the possibility of having essentially a collection of objects, and let me bring back my both circle and rectangle right here, and then we can have a collection of shapes, and you can really use any collection that is available. You can even write your own collection class, right? But the important thing is that now we can dynamically create shapes by using new and create specific ones. But beyond this point, the get area is a function call which is delegated to a specific object, meaning whether it's a circle or a rectangle. So I think we need to go back to the drawing board and explain how all of this fits together, how this works together, and what we need to be aware of in terms of essentially what's happening when your program is running, right? So the entire code fits on these two panels, right? So this is my header file with header guard there, and those 1, 2, 3 classes. One of them is the base class, and the 2 others are derived classes, right? And then the main function that essentially is trying to use instances of these objects. So I would like to go to the drawing board like this and reiterate everything that's going on in this program. So first of all, just a few interesting observations about my entire arrangement. So I have this circle right? I have the circle class, which has the radius, right? And we know that the radius is a double number, right? And we have this get area function, right? Which is, actually, let's just say names of these things. And so when the compiler compiles this class, what happens is that all of the data, which is shown in this section, in the second section of this class diagram, all of this data will be contributing to the size of my object, right? So the size of the object, when the object is instantiated, the size of the object will include this radius double inside this object, and this will be determining the size of the object, right? The size of the object is determined by the size of data members, how come that functions don't contribute to the size of an object? The answer is that the functions are placed in memory. Of course, they're compiled, so there's some CPU instructions for this get area at runtime. But this is a function, right? And when the function is invoked, like when someone makes a call into this function, the function finds its object, right? Location of its object through this pointer. Essentially, every member function of every class, when it gets invoked, it includes internally, not includes, it just gets this as a parameter, and when the programmer writes code to access the data, basically the compiler understands that this pointer will be providing location of an object. So if I created more than one, right, so if for example, if I created another circle and I created multiple circles, right, so if I created another circle, it will include its own copy of the radius, right? And when I say, for instance, to demonstrate, right, I could go back to my original sample here and say that I want circle, and let me just use hard-coded numbers here, 2.3, right? So this will be circle number 1, right? And the circle number 2 will have radius 4.5. Something like that, right? So if this is circle 1, and this is circle 2, right? Whatever the names are, circle 1 and circle 2, right? So I'm just creating these two objects, and if then I say circle 1 get area. Right? If I'm calling member function get area for circle 1, or if I'm calling circle 2 get area. The difference between circle 1 get area and circle 2 get area is that the first time, right? So the first time when get area is invoked as circle 1 dot get area, right? When I'm making this call, get area function is invoked, and this pointer is pointing to circle 1. When I say circle 2 get area, this pointer will be pointing to a different object, to object circle 2. And so this is why the functions are not duplicated for multiple objects. Only the data members will be stored inside these objects and will have unique copies of them. Okay, so that's important. The next thing that I would like to discuss is the next set of discussion points is that we want. Let me just erase some of the stuff, right? Clean this up a little bit. And so now, remember that we also have a second type of object, which is the rectangle. The rectangle. So the rectangle includes in its data section, right? It includes the width and height. And it also has get area, its own version of get area. Get area. And of course implementation, so now if we create a circle object, it will contain inside basically this radius. When we create a rectangle object, it will contain both width and height. So rectangles and circles are different, right? So this will contain two pieces inside this box if I create the rectangle using the rectangle class, right? But the two objects are two very different objects. And so, of course, there will be essentially a circle version of get area, and there will be some compiled executable instructions will be stored somewhere in memory, and of course there will also be a rectangle version of get area for the rectangle. So two different functions will exist in memory because we do have two absolutely different implementations of the two functions, right? So here's one get area for the circle. It does this, right? And there's another get area which does this, specific to the rectangle, right? So when compiled in memory, these two functions, circle get area over here, and rectangle get area over here are two different functions. So when we say that both circle and rectangle classes derive from a shape, right? So we say shape. Shape is essentially an abstract class that doesn't have any data. It only has get area, right? And this get area is declared to be virtual inside shape. We actually derive the circle class from the shape, and we also derive the rectangle class from a shape. So what happens is that when we do something like this, the compiler adds a hidden member to instances of our classes, and this hidden member is called, technically you can read documentation for it, it's called a v-pointer. V-pointer. Let's demonstrate this in the code.